in this composite solid, we want to find its volume, and I can see from the diagram, well, I guess it's a little hard to see. We have a cylinder, and then what has happened is we've taken this hemisphere-like scoop out of the problem. So I want to get that hemisphere moved out of the problem. So my thinking is going to be this. My overall shape, my larger shape, is going to be a cylinder, so I'll need to find that volume. However, since I'm scooping out part of this, the hemisphere, what I'm going to need to do is subtract off the volume of the hemisphere. So that's going to be kind of my thinking that guides me through the process of how to find the volume of this composite figure. So let's start with the cylinder piece. The cylinder, to find its volume, I need to know its base and its height. So let's go ahead and do those, find those two numbers or do those calculations. I can see the height of the cylinder is just 2. From base to base, it's a height of 2 inches. The base then, the area of the base, is a circle. Of course, in a cylinder, your base is going to be a circle. So to find that area, it's pi times the radius squared. So using a calculator to get an approximate answer, the volume of the base comes out to be about 12.56. Recall, either from memory or from your notes, to find the volume of a cylinder, it's the area of the base times the height. So multiplying 12.56 times the height, I get a volume for the cylinder of 25.12. So that would be if the entire cylinder was there, that would be its volume, cubic inches. However, I've scooped out part of this problem. So let's go back and find now the volume of the hemisphere. Well, we haven't talked about how to find the volume of a hemisphere, but I'm guessing you guys know what you need to do. Do your normal sphere volume formula, which is 4 times pi times the radius, which again is 2, cubed, and then divided by 3. Now, the divide by 3 has nothing to do with the fact that you have a hemisphere. The divide by 3 is just part of your formula for a full sphere. But because this is just a hemisphere, half of it, I need to take that volume and then divide that by 2. So there's 2 division steps that you're doing in this problem. So when I did my calculations ahead of time, and I just get an approximate answer for the hemisphere, I got, well, for the sphere, the 4 pi r cubed divided by 3, I got 33.49. Just for the full sphere. That's not dividing by 2 yet. And so if you forget to divide by 2, you can see that there's going to be a problem because your sphere, which is, again, that's the wrong answer, is bigger than the volume of your cylinder, and so you'd get a negative volume, which doesn't make sense in this case. So that would hopefully be a good reminder too if you forgot to divide that by that 2. And again, I'm dividing by that 2 because I only have half of a sphere in this case, not a full sphere. So that gets me a hemisphere volume of 16.75, which is a much better answer because that is smaller than the total volume. So then our thinking was, remember, we're going to subtract those 2 answers. So the volume of the cylinder, scooping out that hemisphere that we don't want to include in the volume, gets me a final answer of about 8.37 cubic inches.